All right. So, so once we have that, we can go back to the wave equation for the electric and magnetic potential and write down the solution right away because we already derived this equation from the full Maxwell equation and using the potential from the Lorentz gauge from the same operator. Now, if you operate on the electric potential, the right hand side is minus 0 over x plus 0. Well, can be x and t. Now, it can be a function of space and time, right? And then the vector potential A would satisfy this equation mu sub 0 times J. Okay, so that we derived in the previous chapter, I think 6.3 or something, 6.2 or 6.3. Okay, but now this is in the form that what we can solve by the green function, or like this, and we separate that into two uh, two situation where the retarded advance, and we usually we consider a retarded solution. This is just what our feeling. We have a feelings of causality. So we think that the present situation is influenced by the past, not the future, and that's just our, I mean, our expectation. May be true or not true. We don't actually know. Uh, but in practical sense, it's just when you usually assume you know the information from the past. So when you integrate over the retarded light cone, we supposed to all this information like past, and you just integrate all those that you know, and then you get the solution at present. So that seems more logical. But this doesn't mean that you advanced solution is no use. In some situation, maybe you know the present or you know the person or the a certain history, but you want to find the solution even before that, then you can use advanced solution that. But whatever the combination of retarded and advanced solution, as long as you satisfy this A plus B equals 1, that suppose it should be exactly the same solution. As long as you know the information, you know how to do the integration. But we will stay with the retarded solution. So we can see what the label. Actually, Jackson doesn't even say the label. Just write down the solution using the retarded solution. Then that this one, hmm, just uh, just just right there. Uh, 4 pi epsilon c. This 4 pi is because in the formulation we multiply by 4 pi in the when we solve the green function, we have 4 pi times the delta function. So you need to multiply 4 pi into 4 pi. So there's a 4 pi. Okay, and then you integrate. So rho x p pi, we put it in the retarded bracket. Divided by okay, so that would be the solution, at least almost solution, the retarded solution. And you see that this is very similar to the electrostatic solution that we learned from last semester. In retarded solution, I mean, electrostatic solution just because it doesn't depend on t. So rho becomes just a function of x, and you can get rid of this retarded bracket, and that is exactly the solution that we found in the for electrostatic. So that kind of normal, or you expect that. And the vector potential will be similar. Now, instead of epsilon zero, you have mu sub 0. And you have the point density depends on x pi and t pi. You put that in the retarded bracket. And see what the x is x pi. So that is also similar to the magnetostatic solution that we found. So everything is everything just work out. All right. So that's supposed to be the end of it. You can, once you have the potential, you can, I mean, scalar and vector potential, you can find the electric and magnetic field. So B is easy. B is just typical. Then you find your B, and E will be minus scratch pi partial A partial T. And in principle, it's doable. So after you evaluate all these integral, all this right hand side will it just depends on x. This is x depends on x and t. Right. So you can do all these derivative and get b and e. So that's one way to look at that. But another way to write down your solution is instead of doing derivative if after you do the integration, you can do a derivative of the equation itself and show that like say, for example, B is trivial. B is you take the curl of this solution, this equation, take the curl, so that become curl, that's become B, this become curl of J, right? And you can show that. Okay, write down that first. Now this becomes B. The right hand side will be minus mu0 curl of J. Right. Then right away you can write down B solution also using this exactly the same method. B mu0 4 pi, except that now instead of J here you put the curl of J. But when you put the curl here, this is a gradient with respect to the pi, because now J is depends on x pi and t pi, and that then you do a entire bracket. But that you need to be a little careful in this uh, in in this formulation, because t pi, this retarded bracket means whenever you see t pi, you change to t minus x pi over c. So there's an x pi here. When I do a derivative x pi, this formulation is saying that we are doing the derivative over this x pi variable, but not this x pi and t pi. Only after you take a curl and then you evaluate t pi equals zero. So that's just like this retarded label. It seems like a little confusing. Sometimes what you can do is do an extra bracket, do a curl of J first. Curl, but then evaluate pi code, curl pi of J, and that would still be a function x pi and t pi. Then you do the retarded bracket. Okay, yeah, that is that's a little bit careful to confuse. Okay, so that's B. And similarly for E is just grad phi, and then minus grad phi minus partial A partial T. Then you can write down the wave equation of E, and the right hand side is whatever you take the grad rho or negative grad of rho and partial J partial T or minus partial J partial T. Right. So that is you can write it down right away. Here. That will be the last thing we write down because about time. So E T will be just using exactly what we did. You have, all these have a negative sign, so you might as well take the negative sign out. So negative one, efficiency, integrate. And finally, everything will be inside a bracket. And if you take the grad pi of rho and now that value of pi equals, and then you have a partial t, and then when I take the partial t is over this, but then when you use the green function, this t becomes t pi. So you can actually that becomes a partial t pi a, and this partial t pi, and then do the retarded. Okay, that would be. Oh wait. That would be because this equation have a mu zero, so you need to you get four epsilon zero here, so you divide it by epsilon zero, multiply by epsilon zero, that would be 1/c squared. So you need that to make it dimensional. Okay. So that would be equation 6.51. Okay. So you can also use that to use this and that as your B instead of getting A psi and A and do this. So either way is a valid solution, but depends on situation for which one actually easier to solve. Okay, so there will be a little bit other discussion. We'll finish that and so to move on to our topics. Okay, so we'll stop here.